All right, any questions before we get going? All right, last time we finished off talking about these for loops. So a for loop, it's a loop, like a while loop. But a while loop will run for any arbitrary Boolean condition. Right? You put in some Boolean expression that gets evaluated to true or false. And while that expression is true, the while loop will continue to run. Just like an if statement, except it just keeps going until it's not true anymore. The for loop here is a little bit different. And I gotta warn you, if you have experience in Java or any other programming language, you're probably familiar with for loops. But if you are familiar with for loops in those programming, raise your hand if you've got experience and you've seen for loops before in another programming language. Okay, not too many people. I'm going to warn you, these for loops in Python aren't your typical for loop, where you just start somewhere and you keep counting. These are for each loops. So I don't know if you use those in your other programming languages, but these are more like the for each loops. And in this example, we've got A. A is some arbitrary string. It's that collection of characters. And this is just review from yesterday's. Where did I say it? Well, whatever. A is some arbitrary string. And then I say for each thing in this collection of things. So the collection of things is referred to as A in this example. And char is an apt variable name that will hold on to the iterations, the loop's iterations, current thing from the collection of things. First time through the loop, this will be the 0th character, if A is a string. The next time through the loop, it'll be the 1 at location 1, and then 2, and then 3, and so on. So if we go here, here's the string. I called it inster. C, for the first time this runs, you know what, I'm going to add a counter here. Oops. Can't use that. There. H corresponds with like 0. And then the loop finishes and we add 1 to the counter. We go back up, counter's now 1, and we get the next character. So in here, the order matters. It's going to take this collection, it's going to take the things from the collection of things in order. And you remember how we could index. We could even do something like this. I'm not going to hit run yet. I want you to take a second and think about what the output should be. You've seen all this before. So take a second and see if you'll know what will be printed out. Just a quick poll. Raise your hand if you think you know. Like, I've got an idea. Really high, I want to see. So a number of people are still a little like, I don't know. Now, you have all the tools in your tool belt. Here we go. Counter equals 0. Inster is some arbitrary string. In this example, it's hello, comma, space, world, exclamation point. Counter starts at 0, and I say for each C and inster. Okay, great. I'm going to print out counter. What should counter be right now? Yell it. Then I print out C. What should What should C be right now? Did someone just say true? Because you shouldn't have. An H. C is going to be H because it's the beginning of that string. And this is the first time we're running that loop. Now let me ask you. We know counter is 0. You just said it. What is inster at counter? This time through the loop. What will it be? H. it just prints out the character again. Which is kind of neat, right? So we're seeing how we can use this for each loop to access the individual things in the collection. Or we could just index the original string at the corresponding location. Any questions about this? I do admit I get a little worried when it gets this quiet in here, because I don't know if you get it or not. I know this year it's funny, you've got your masks on and whatnot. Maybe that's affecting it. But, I don't know, I've never had a group so apathetic, which is concerning to me. So any questions about that? All right. So, mutability, it's a fancy word that means changeable. Here's what I mean. I can do, if I go down here, I can say A equals 6, print A. And then I can go A equals 8, print A. It's all happy. I was able to go into that variable and change its value. This isn't new. We've been doing this for ages. So we're okay with this. It seems as if integers are mutable. I can do something like this. We can clearly change what the variable, like the string variable is, like what the string it has is, right? You see this? First A was the string hello, and then I printed it out, then I made A the string world, and then I printed it out. Nothing mind-blowing, right? So here's the question one might now ask. I can do this, right? Remember, we can access individual letters from the strings with these square brackets. We are allowed to do this. So if we can access that information, like I can access A, and I can access A at location 0, 1, whatever. Like I can get this information. Like let me go down here. I can say A, and it'll give me hello. I say 0, it gives it back. Like it gives me back the one at that corresponding location. A natural question one might ask now is, well, if you can access those elements, you can access the individual letters, right? The characters in that string. Can I change them? Seems like a reasonable question, right? Here's what I mean. I can say print just like that. Can I say A at location 0 equals B? That's the question I want to ask. I can access A at 0. I can get information from it, but can I put information into it? Can I change the information that's in there? Gets angry at us. String object does not support item assignment. This is a long and fancy way of saying we can change the string that a variable has, but we can't go inside that string and change that string. We can change what the variable value is, but we can't go to what this variable's value is and then change that value. If you're thinking wait, that sounds like I'm explaining the same thing, you're not crazy. It does sound very similar. But very soon, we're going to learn a little bit about how... Just sit tight. Here's what I mean graphically. If I have A and it gets me to hello, I can go and say, okay, A, become this other string world. You know, I can just do something like this. Right? So A is world, right? But what it won't let me do is go into here and change what's in here. That's what it won't let me do. I can change what A is, but I can't change the details that are in this particular string. Is everyone okay with this? Yeah? Oh, all right. No questions or anything. Who here? Yes?
Did you, like, delete something out of it, or?
Well, let's try. No. We can't change it. Once it's there, once this string exists, we can't go and change this string. There's a good reason for that we will learn about soon. Are there any other questions or thoughts about this? Yeah.
Does this only work for strings, or does this work for like a list of?
Ooh, that's a very interesting question that we will come back to shortly. But I like the way you're thinking. Any other thoughts, concerns? All right. So I guess I'll get rid of this because it gets mad at me. There. So this is just me saying, yeah, you can't do that. But if you really want to go and replace this O with an I, let me go back. If I really need that O to become an I, there's a way I can do it, kind of, but I'm not doing what I'm saying we're not allowed to do. I'm not going into the string and changing it. Here's what I'm going to do. I can say, give me the string all the way up to index 7, but excluding it, and then add the new thing in there, and then get a copy of 8 to the end. In this example, I might write something like this. I would be allowed to write this. Get a copy of the W, append the letter, that's saying X, I'm going to make it I. You know what? I'm going to take this a step further. A at 0 plus I plus A 2 colon. Because what that says is, get me this first letter. Okay, it's a W. Append an I to it, and then append these letters. I'm not changing this. I'm making a new string with copies of information in here. And then when I say A equals that, well, there. It would then become, well, that would ultimately become WIRLD. It's getting a little smushed there. It's hard to see. But anyways, that's what would happen. Let me just type it out just to go through it one more time, because this is pretty cool. I want to change this hello to holo or something. So the point I'm making is I am not allowed to say A at 1 equals O. That's, oops, not minus. That's not allowed, because that means go to the word hello and try to change it. No. What will work is A equals A at location 0 plus O plus A at location 2 to the end. Okay. Actually here, I'm going to make it B. Great. If I print out A is still going to be hello in that example, right? But what this means is, oh, go get me what's in there. This is going to give me back a copy of that thing. Then I'm going to append the O, and then I'm going to get a copy of L to the end. That's what it's doing. So this makes a whole new string that's based on the one I started with, but I never changed the one we started with. I had to like clone it kind of and then modify it in the cloning process. Questions about that thing? All right. So, activity, yeah. Write a function, char is in. That returns true if the character char happens to be in the string. And you know what? Do me a favor and ignore the what does the in operator do. Ignore that. Ignore that completely. I want you to write me a function that takes a character in a string, and you need to tell me if that character is in that string. Okay? That's the job. This is a tricky one. Take your time with it. I'll give you a couple minutes for this one. Anyone get it yet? No? I was just asking. Keep going. Raise your hand if you're done. Raise your hand if you think you're totally going to have it. You just need like 30 more seconds. Okay, I'll give you the 30 seconds, and then we'll work through this one together. Okay, here's where I'm going to start from. I'm going to have to go through that string, right? I got to look at each of those letters, because the question is some character in some string? So I need to go through each letter in the string and check if that's the character I'm looking for. That's the question. So I'm going to have to loop through each individual letter. You know what? I'm going to call this, I'll leave it the way it is. I got to go through each individual letter. The way I've written my for loop, what is going to be referred, how are we going to get access to individual letters based on the code I have? What's the name of the variable? I can't hear it. Someone said something.
Cur_c.
Cur_c?
Cur_c, yeah.
Yeah, the cur_c. Current C is going to be the individual characters. So if you're a little worried, when in doubt, and then we just go down here and call it, A. It's not going to do, this is clearly not doing a lot. But I'm printing out cur_c currently to show, yes, okay, cur_c is in fact going to put its finger on each individual letter. So first, if we have hello, the first time through the loop, cur_c gets me H, then cur_c is E, then L, and then O, and then that's it. So, how on earth, I don't want to print C, that's not useful. What do I want to actually do here? Who's got an idea? What do you say?
You want to see if cur_c is equal to whatever in C is. Well, whenever S is. So whenever you give adds in C, it means, right?
So what you're saying, let me see if this is what you mean. If in C,
Yeah.
look at this. If this is confusing you, slow down. It shouldn't. We're going to put our finger on each letter here. And I want to say, okay, it's H. Is H the thing I'm looking for? Yes or no? If it is the character in the string? Yell. If it's not, what do we have to do? Return false. Okay. Let's try that. If in C is equal to cur_c, return true. And then, this was the idea, right? Hold on. Some people are shaking their head no. But let's try this one. Let's try H. True. It tells us this H is in that string. Great. Looks like our function's good, right? Let's check if like X is in there. False. It's not in there, right? But there is a huge bug in this code. And if you're a lazy tester, like I have been so far, you might never catch this bug. You think you're right, you test it twice, checks out, must be right. Well, let's just check if E's in this string. Is E in the string hello? True. And we get false. Take 10 seconds, look at this code. You better know why this is a problem. Like what the problem is, I mean. Let's run through this code like we're the robot executing it. I've got the string H. I'm looking for the letter E. Okay? So, cur C. Cur C is H. Great. And then I ask the question, is in C, E equal to H? False. So it's false. So, false is not true. So we immediately jump down and we get to the else. And what does that else say? Return false. Oh, okay, so I return false. I'm good to go. That's what the code says, at least. Here's the thing. Let's say I was looking for the letter O. When do I know whether or not O is in the string I'm looking at? Let's say I look at the first letter. Do I know if that string contains the letter O or not yet? I don't know. I look at the first two letters. Do I know if O's in this string yet? We haven't seen it yet, but I don't know. Do I know now? Do I know now? Do I know now? Let me put it this way. When do I know whether or not the letter X is in the string? I look at H. First time through the loop. H. Do I know if X is in the string or not? How about now? Now? How about now? It's got to be now. Why don't I know that X is not in the string yet? Or, wait, did I word that right? Why don't I know? Why can't I say yes or no at this stage? Because there's one letter left. And that might be an X. I don't know. I haven't looked at it yet. I only know if something is not in the string until I've looked at all the letters. That might seem painfully obvious to you. Good. But this critical idea, you know intuitively, well, yeah, you won't know until you evaluate all the letters. That's obvious. But here's the problem. You might have this idea in your head, like you've got that intuition, but breaking that intuition down into the steps of the code is a whole other story, right? And now I'm just explaining things closer to the code. I only know whether or not something is or is not, I only know if something is not in this string until I look at all the letters in the string. But conversely, let's say I'm looking for the letter E. Is this E? Is this E? Oh, okay. When do I know if a letter is in the string? Do I need to keep going all the way to the end anymore? No. You were about to say yes. The question was not how many E's are in the string. The question was, is E in this string or not? Pretend there's 1,000 E's after here. I get to this one. Do I need to keep looking anymore for E's? No. We know we found something as soon as we find it. But we will never know when doing a linear search like this. We call it linear because you start at the beginning and you go like in a straight line to the end. You'll never know when doing a linear search like this if something is not in the string until you get to the end. Let me put it this way. In this actually here, this little idea, linear search. Actually, let me raise your hand. Okay, so let me fix this, of course. There. If it's the one I'm looking for, return true. If not, do nothing. Just keep going. The loop will resume. Then I put the return outside of the for loop. Because when that for loop is done executing, that's when I know I've exhausted everything. And only after I've gone through that whole string can I definitively say false. I cannot say false any moment before I've gotten to the end. So, I mean, I gave you a couple minutes to try this one on your own. I did it with a for loop. We could have done it with a while loop. Doesn't really matter too much. But only a couple people got it. That's fine. Because this here is like perhaps your first real computer science-y algorithm we've looked at. Something as simple as a linear search, but we love talking about searching in intro computer science because it's a very understandable problem, but it gives us a chance to kind of poke and prod this well-understood problem kind of with our computer science hats on. So, for those of you that didn't get this, I'm just kind of curious, what was the bit, like you look at it now and you're like, oh yeah, okay, yeah, great. But what was the bit that was tripping you up? I'm just kind of curious. I'm looking for a couple ideas.
I didn't have the return example. Like I had it how you originally had it. I didn't have I had the return for false where you had originally had it.
So you were darn close. Well, anybody else have something close-ish, but they couldn't quite get it?
I was trying to use square brackets within the S to determine the...
Yeah, and for that you need a number to index the whole thing. Yeah, that's okay. So let me ask you something right now. I'm interested in how much work our algorithm is going to do. Okay? And we're going to think of work as just like how many steps does this algorithm take? And I want to think a little bit about like the worst case scenario. Best case scenario is I'm always looking for the first letter. And it only needs to run that loop once. Because it finds it, great, we're done. The worst case scenario is we're looking for stuff that's not in that string. Because we got to go all the way to the end before we know if something's not in that string. So let's say I've got a string of size 10. And I'm looking for a letter that's not in there. How many times is that loop going to run? Yell it. I'll say it again. I've got a string of size 10. I'm looking for a letter that's not in there. How many times will that loop run? Somebody yell it. 10. Let's say 20. Let's say 1,000. Seems obvious, right? Let's say it's the size of that string is n, where n is just some arbitrary number. How many times will that loop then have to run? Let's say my string is size 2n. How many times does that have to run? 2n. The amount of work that this function does is directly one-to-one related to how long that string is, right? The longer the string, the more work it has to do. If I double the length of the string, I double the amount of work that I have to do. Right? Now this might seem really obvious. Good. But this right here is your first look at some perhaps slightly more real computer science stuff. This is what we like to geek out about, is how much work is this function going to do? There are functions that we're going to look at in this class that when you double the size of n, the amount of work the algorithm has to do will like quadruple or something. Or sometimes when you double the size of n, you only need to do just like just a little itty bitty little bit more work. There's a lot of different algorithms that are faster, slower, and whatnot. But this is what we call a linear time one. As the input grows, the amount of work being done will grow just the same. Yeah?
Why would you ever use that instead of, like, if char in string return true, else return false?
Ooh, well, I would never do what you wrote.
You said I wrote that.
Oh, okay. I would never do it that way. So you're right. In Python, there's a built-in function called in, or an operator called in, that will tell you, like, oh, is this in that collection? Obviously, you'll see that there's an in the for. In is context sensitive. If in is used inside a for loop, it works one way. If it's outside, it works another way. That's like Python's like the only like big programming language that has this built in. All the other beefy, big, real programming languages don't have that for free, and you're going to do something like that. But let me ask you, that in operator that you're talking about, want to guess what that code's doing in the back?
It returns true either way.
It returns true. It's going to be correct. But you want to know what's really running in the background when you... Something just like this. So you're basically, it's kind of like, imagine I called my function like this or something. It's basically in is another name for a function that just does exactly this. Now, I was just going to tease you because you were saying if C in S.
Yeah, that's exactly what I had.
Who can tell me what is horribly, horribly, horribly wrong with this code? Who remembers? I ranted about this briefly a couple weeks ago. I want to be very clear. There's nothing actually wrong with it. This will be correct. I want to give people a chance to think. Here's what I would write. Oops, I guess I need to do. I can do this because what you were suggesting, and I'm just teasing you now, is C in S will return either true or false.
Oh, it's like cringy.
Bingo.
Programming.
It's like if true, return true. If false, return false. Well, I mean, that function returns true or false. Kind of like the middleman there, I guess. Anyways, I'm just teasing you. There's nothing actually wrong with doing it that way. Okie dokie. So we already talked about this. Here I'm doing it with a while loop, and I've got the return false. The issue we just explored. If we were to modify this, where is? Imagine I wanted to modify this real quick. I'm going to go back in time. I wanted to modify this not to return true or false, but to return the index of the first instance of that character. If there's 100 E's, I only care about the first one. Well, there's a really easy way to do this. And I'll show you. You'd be able to figure this one out on your own. Just create some sort of counter. Start it. If we find it, return counter. Otherwise, add 1 to counter. Then down here, I guess maybe I'll have to like return -1 or something to mean like, well, okay, I didn't find it. Look at that. It worked. I know I did that a little quick, but you should be able to look at this and find it accessible. All I did was create a counter that counts with that for loop. Every time the for loop runs, add 1. So that counter and the character will correspond. And then if I find it, return the counter. That return -1, that's a classic example of like, okay, this function's supposed to return a number, but what should I return if I don't find it? Because I'm supposed to return numbers, so I can't return false. So I need like a special flag or something. So me as the programmer, I would say, oh, it returns the index of the first counter. If the character isn't found, return -1. And then anyone using it would go, oh, okay, if it's -1, that means they didn't find it. It's just like a special flag or something. Any questions about how I made this work, though? Also, remember, I don't need the else here. I could add it, and it's still going to work just fine, because the return... And the reason I didn't need the else was, if the condition is true, I go inside, I hit the return, the function stops immediately. If it's false, I skip the if statement and carry on. Basically, if it's ever true, it'll never run what's below, as a consequence of how this is written here. Any questions about this? So I'm going to blitz some string trivia. Don't worry about memorizing this. You'll have a reference here. You've got Google. It's just stuff to know. You can use single or double quotes. Great. But if you really want to use single quotes in the string itself, you got to use double quotes on the outside. You can concatenate strings. You can make a string repeat. We've seen that. We can convert strings to integers and vice versa. Strings can be empty. There's actually a bunch of special characters. If I write /n, it'll add a new line. So you see hello, new line, world. /t, take a wild guess what /t does based on this output. Tab. Here's a funny thing. Computers are zeros and ones. Low voltages and high voltages, right? That's all. Zeros and ones, we can easily convert to integers, right? Because there's, it's just a binary number system and we need, But here's the funny thing. The number 97, which we don't have in binary, but the number 97 corresponds to the letter lowercase a. See near the top right? 97 in decimal is lowercase a. If I had the series of zeros and ones that corresponds to the number 97, okay? Actually, let me do a real quick Google search here. If I had, ignore the 0b, that just means, oh, it's binary. If I had 11000001, and I gave that to the computer, 11000001, okay, that's information for the computer. The computer needs to decode this 11000001, or high, high, low, 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 high. It's got to decode it. But the computer won't know how to decode unless it knows what type to decode it as. If I had 11000001 and said, what is this as an integer? It's going to say, oh, it's 97. But if I say, hey, no, what is this as a character? It's going to say, oh, it's A. So the number 97 and the letter A have the same 0 and 1 sequence. It's all dependent on how we decode that sequence. So when we're programming, we're encoding information into these low voltages and high voltages. We need to decode them as well, but we need to know how to decode them. It's kind of neat to think about, right? How, wait, I guess, yeah.